Hey guys, just another quick video about Tetra here. I wasn't too happy with the video that I released yesterday about capturing tetra-C files in DragonOS LTS. I was too hyper-focused on the actual capturing a C file part, where in fact we don't even really need to do that. We can just capture the bits to a file, and then we can just use tetra-rx from Osmocom Tetra just to decode that file. So I don't know what was wrong with me and getting so focused on capturing a C file. So what we're going to do is we're going to use DragonOS FocalX. I'm just using R35, but it should work on any of the DragonOS FocalX distributions there. To make it as accessible as possible, we're using a virtual machine, as you can see here. And I'm also just using my RTL-SDR blog v3 here. So that should just make it accessible for everybody there. So let's get stuck into it, shall we? So what we need to do is we need to open up this GNU radio flowchart here. And these files are in user source, which is sort of like a super user directory. So what we're going to do is we're going to save that file to our home directory here. Press save, close that. Now we've got this GNU radio flowchart. This is actually from tetra-kit, developer Larry. So we're just going to steal and edit his flowchart here. So we've got a few things to change, guys. So I'm going to scroll down to the bottom and we're going to delete this missing block here. I've actually got the instructions here. So we'll just follow along with those instructions there. I'll just lift this up so we can see where are we up to here. Righto. So we've deleted the missing block now. So we're going to right click on file sync, which is here, and we're going to enable that. In the sample rate box, which is up the top here, we're going to change that to a sample rate of 1000. That will work with an RTL-SDR just fine. Press OK on that. The next thing we do is we change the frequency. So you guys will obviously have to have a known Tetra downlink frequency. I'm using this one here, which is from the casino here in Darwin. So I'm going to paste that there. I'm going to hit apply. We're going to double click on RTL-SDR Source. We're going to change the gain mode to manual. And then I'm just going to set a gain of 40. But yeah, obviously you guys will set that to whatever gain is required for your project. Obviously, if you live next door to a Tetra transmitter, you'd want very low gain, obviously. And if you're far away from the transmitter, you want high gain. So that's how all that works. What else do we need to do? That's everything with the modifications of the flow graph. So we're going to hit this button here, which is generate. And then we can see here that a Python script has appeared in our home directory here. And we're going to press play. Now the nice thing about using tetra-kit is we actually get this Pi4 CQ PSK constellation here. So this is a good troubleshooting thing. If you don't have all these small dots arranging themselves into 4 larger dots here, that means you don't have a good signal. So yeah, we kind of want these are like the symbols. We kind of want the symbols grouped into like 4 separate dots, if that makes sense. So yeah, we're just going to leave that run because we've got a few other things to do now. So we're going to download, we need to download Osmo Tetra. So I'm guessing you guys have already done that. If you followed my tutorial the other day, but we're using DragonOS FocalX for this. So I'm guessing you guys haven't done that in this particular distribution yet. So I'll just clear my terminal. Oh yeah, and by the way, we can see the flow graph is outputting this file called out.bits. And now this is the raw demodulated bits coming out of the flow graph here. So that's a good sign so far. Even if you don't tune into a Tetra signal, that will still grow in size. So don't be fooled thinking that, oh great, I'm getting Tetra data, because you're probably not. Unless you've got this nice PSK constellation arranged into the 4 dots. So that's your confirmation that you are actually getting Tetra. Okay, anyway, sorry, that's a tangent. Try and keep this video nice and short. So yeah, we need to download the Osmo Tetra. We're going to use the SQ5 BPF fork of that, because it's got some nice features that the normal Osmocom Tetra doesn't have. We can see here in our home directory, we've got the program files downloaded. And then I'm going to run this combination command here, which is going to cd into the source directory of Osmo Tetra, and it's going to make it. So we can see, yep, we've got a bunch of objects, files, and some binaries get built there, so that's great. Back to the home directory. And then we run this final command here, which is going to address tetra-rx. And it's going to decode this file that's been created in our home directory, which is currently growing in size. I can just show you guys that. I'll put that here. And yeah, you can see that that's actually growing in size quite quickly, so that's a good sign. And I'll just hit enter on that. And there we have it, we've got data. So yeah, that's how you do that, guys. So yeah, I'm not sure if I'm going to post this video yet. I might just send it to my my Tetra buddies that have been chatting over email. But yeah, if I do post it, well, I hope you guys enjoyed the video. Thank you very much for watching. Bye.